Okay, let's dive right in. You know that feeling when you're using an AI tool at work, maybe in a lab or on a factory floor, and it just feels like you're trying to drive with the emergency brake pulled? It's clunky, it's slow, it feels like it's full of roadblocks. Well, today we're going to talk about why that feeling, it's not a bug, it's actually a critical safety feature.
I mean, it's a totally fair question, right? Especially when you think about how slick and fast consumer AI tools are. You're just trying to get something done at work, and it feels like the system is actively fighting you at every turn. It just feels like one frustrating roadblock after another. Like, for instance,
You're stuck in this maze of constant approvals. You need to put in a request for practically everything, get another sign-off just to take the next logical step, and then just when you think you're finally getting somewhere, bam, you hit a wall. Restricted access. You can't get to the data or the function you need to actually do your job. And when you add up all these little hurdles,
You get this feeling that your workflows are just delayed. Everything takes forever. It's a super common frustration. I get it. But what if I told you that all that friction, it's there completely on purpose?
yeah, you heard me. This isn't some bad design flaw. It's an intentional, absolutely essential safety system at work. This system is all about managing authority, risk, and accountability. And it has a name. It's called a control plane. So, okay, what is a control plane? Well, you can think of it like the brain of the entire operation. Before any AI-driven action can actually happen, before anything gets executed, the control plane jumps in. It checks the rules, it confirms who's making the request, and it weighs the risks. And only if everything checks out does it give the green light.
And this right here is the key takeaway. All that slowness, all that friction you feel, that's the safety system doing exactly what it's supposed to do. That friction is the mechanism that protects operations. It's the very thing that prevents a catastrophic error before I can ever touch a critical piece of machinery or a sensitive lab instrument. We're talking about preventing things like accidentally changing the formula for a medicine or, overheating a reactor.
So how does this thing actually work under the hood? Come on, let's peel back the layers a bit and really see the architecture that makes it all possible.
Okay, so the whole system is basically built in three distinct layers. Up top, you've got the control plane. That's our big decision maker. Then in the middle, there's the execution plane. That's where things actually, happen. And down at the bottom, you have the evidence and audit plane, which records every single thing for accountability.
Now, to really get why this structure is so important, you have to understand the huge difference between two worlds, IT, which is information technology, and OT, which is operational technology. IT platforms, they're all about flexibility and iteration, moving fast. But OT platforms, we're talking the machines on the factory floor, the instruments in a lab, their priority is stability and safety. Predictable operation is the name of the game. So an AI platform that has to touch both of these worlds, it absolutely has to play by OT's rules. All right, let's trace the path of a safe, approved action through this system. See that amber line? A request comes in. The control plane checks the policy. It runs some validation checks, and then it sends it through the right approval gates. A great way to think about it is like an air traffic controller clearing a flight plan. Only after every single checkpoint is cleared does that command get passed down to the execution plane to actually do something.
Okay, but now for the really cool part. What happens with an unsafe request? Well, if an action is non-compliant, or it's unauthorized, or it's just plain too risky, the control plane doesn't just say no. It issues a hard stop command. It's like slamming on the brakes. And this is what prevents that dangerous action from ever reaching those sensitive OT systems. This is the system, right here, preventing a potential disaster in real time.
Now, I know this might seem like a bit of overkill, but in regulated environments, think manufacturing, life sciences, the consequences of an error aren't just a software bug or a bad recommendation. The stakes are way, way higher. See, an AI error in these fields can directly impact product quality, or even worse, patient safety. It can lead to major regulatory compliance issues. It can even trigger a physical process that could be incredibly dangerous or totally irreversible. Errors here can spread fast and be almost impossible to undo. So yeah, you just can't let the AI run free.
And that brings us to a really critical idea here: implicit authority. Without a control plane, an AI system just acts. It just assumes it has the authority to do whatever it's been told. But in these high-stakes environments, that is a complete non-starter. Every single action needs explicit permission. And that is exactly what the control plane is there for.
So what this all means is that we need a real shift in how we think about AI in these spaces. The goal isn't just to be fast. The goal is to be safe,
to be compliant, and to be accountable. The focus has to move from raw speed to really robust governance.
So, next time you're looking at an enterprise AI platform, don't just ask, hey, how fast is it? Instead, you need to be asking these questions. First, what's the right level of authority this system actually needs? Second, how strong are its governance features really? And third, and this is the big one, are we prioritizing safety over just the surface-level feeling of speed?
And just to be super clear, our goal with this explainer is to give you a mental model, a way to think about how these systems work. This is not about ranking specific vendors or telling you there's a single one-size-fits-all architecture. It's about giving you the tools to reason about why these platforms are built the way they are.
You know, when you boil it all down, it comes back to this really powerful idea. The reason these enterprise platforms feel so different from the consumer tools we use every day is because they're built for something else entirely. They are built for accountability.
So, I'll leave you with this question to chew on. When you look at the AI systems in your organization, are they just built for speed, or are they engineered from the ground up for trust? Because that answer, that makes all the difference in the world.